Hi everyone, and welcome to the Mat 211 review of the binomial distribution. My name is Julia, and I work for the tutoring centers at ASU. So, 10 independent Bernoulli trials are performed with p equals 0.2. What is the probability of at least 9 successes? So recall that when we have multiple independent Bernoulli trials, this forms the binomial distribution, where we can say that the probability that some variable x equals a little x, where little x is a particular outcome, that is equal to the binomial distribution, which we can represent with a b, of n, x, and p, where this is little x, as is this one. And this notation here of the binomial distribution, this can be written out more explicitly as n choose x times p to the x times q to the n minus x, little x here, where q is equal to 1 minus p. So p is the probability of successes in this case, whereas q represents the probability of failures. And we can think of, we call this successes and failures, but we can think about the successes as being whatever target variable we're trying to measure. So if we were working with, somebody shooting arrows at a target and we wanted to say the amount of hits that they got versus the amount of times they didn't hit the target, that would be an example of the amount of times they did hit the target would be their successes, and the amount of times that they did not hit the target would be the quote-unquote failures. So, but in this case, we'll just stick with the generic successes and failures. So when we describe these couple of variables here, there's a few important things to remember. So we have little x here, we have n, and we have p. We've already talked about p, that's the probability of success. N is the total number of trials. And little x here is going to be the number of successes, number of target successes. So we have, so far, we know that p is equal to 0.2. And we need to calculate our other variables or figure out what they are based on our problem here. So we need to know what n is. We need to know what x is, or little x here, with curly x. And we need to know what our q is. Well, q is straightforward. We know that p is 0.2. So using this formula that we wrote down here, we have that q is 1 minus 0.2, which is equal to 0.8. So we've got q. Now we know that n is our total number of trials. Well, from our problem statement here, we have that we're doing 10 independent Bernoulli trials. So n is going to be 10. And x, well, x is a little different here because we want at least 9 successes. So that means that what we want here is that x is greater than or equal to 9. However, note that we only have 10 trials, so x can be equal to 9 in this case, or x can be equal to 10. Those are our two options here. So what we need to do is we need to calculate the probability that x is equal to 9 and the probability that x is equal to 10, and then we can sum those together to get our total probability that x is equal to at least 9. So let's go ahead and do that. We'll start with doing the probability that x, big X in this case, is equal to 9. And so this is going to be our little x here. And that is equal to the binomial distribution with n equals 10, little x equals 9, and p equals 0.2. And remember that when we say p equals 0.2, coming along with this is that q is equal to 0.8. So this means that we're going to have 10 choose 9 times 0.2, our p, to the 9th power, so this part here, times our q, which is 0.8, to the n minus x, so 10 minus 9. So this is going to equal, if we put this in our calculator, our 10 choose 9 here is equal to 10, so that'll be 10 times our 0.2 to the 9th times 0.8 to the 1st power. And if we calculate this, we get approximately 4.096 to the times 10 to the negative 7th. So a very, very small number here. So let's write that up in the corner so that we can erase here and calculate our probability that x is equal to 9, or x is equal to 10. So the probability that x is equal to 9 is approximately equal to our 4.096 times 10 to the negative 7th. We'll just put that to the side for now. So now we can go ahead and figure out what our probability that x is equal to 10 is. It's going to be the same exact process. We have the binomial distribution with n equals 10, little x equals 10, and p equals 0.2, which is going to equal 10, choose 10, times 0.2 to the 10th power here, times 0.8 to the 0th power here. Well, 10 choose 10, you can verify this in your calculator, but there's only one way to choose 10 out of 10 as a combination. So this is going to be equal to 1 times our 0.2 to the 10th power times anything that is to the 0th power equals 1. So 0.8 to the 0th power is 1. So we're just going to multiply this by another 1. So all we really end up with is this 0.2 to the 10th power here, which equals 1.0, or approximately equals, that is, 1.024 times 10 to the negative 7. So an even smaller number. So let's write that up in the corner here real quick. 0.24 times 10 to the negative 7. Perfect. Now that we have both of our specific probabilities of the value equaling one of our two possible values, we can go ahead and sum these together to figure out our total probability. So this means that the probability that x is greater than or equal to 9 is equal to the probability that x is equal to 9 plus the probability that x is equal to 10. And remember, these are all big X's in this case. And that's going to equal our probability that x equals 9, which is 4.096 times 10 to the negative 7th, plus our probability that x equals 10, which is 1.024 times 10 to the negative 7th. And well, and this will approximately equal this. That's important to note because this is a rounded value. And this is equal to 5.12 times 10 to the negative 7th. So a very small number indeed. And this is our answer. So we have, this is what we were looking for. That's the probability of at least 9 successes here. And this is our final answer. So before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can visit the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for tutoring services for your specific course, you can use our tutor search tool, which you can find on our main website here, or by going directly to the tool at this full link. So thanks so much and have a great rest of your day.